Okay, here we are working out the key for the practice test for the geometry unit riddles. Alright, if I am a quadrilateral, that means I have four sides with exactly one pair of parallel sides. Start off thinking, okay, there's a side and it's got to be parallel. Don't make it the same length if it doesn't say so. And I'm going to even make it a little bit more random. So that's parallel. Mark them parallel. That's not parallel. That is a trapezoid, okay? I am a figure with three 60-degree angles. What am I? I am an equilateral triangle. So you can just mark it like that, and that is equilateral triangle. I am a quadrilateral, again, four sides with perpendicular but unequal diagonals. Diagonals are the things that connect opposite vertices, like that. That's a diagonal. That is a diagonal. If they're unequal in length but they're perpendicular, start off with like a short amount, okay, and then do a long amount, okay, and then ask yourself, do you have two lines of symmetry? Well, this is a kite shape, and so that's close. That only has one line of symmetry. In order to have another line of symmetry, it's got to be exactly equal down below. So think of a squashed square, something like this. Line of symmetry, perpendicular diagonals. That is a rhombus. That is going to be the same length all the way around. Okay, so rhombus. And here, identify using the most accurate name. This also is a rhombus. That's a bit boring. Sorry to repeat myself. But all we know is that those four sides are the same length. We do not know that that is a right angle. We do not know that that's parallel. You will have to see marks for things that are telling you what they are. Don't just assume based on the way it looks. Alright? Describe with the help of small diagrams how to construct a square using GeoGebra. Alright? So keep, what is a square? A square is going to be like this. Four equal sides, four right angles. That's the definition of a square. So you're going to start with any old segment. That's step one. Step two, you're going to then make the segment have perpendiculars like that. I'll fill in words, but I don't have time to do that now. And then step three is that when we've got this segment with these perpendiculars like this, we're going to make a circle that has this point as the center, and again you can do a little arrow, center, and this is going through the circle like this. So now these are the same length, and then so step four, you're just going to take that thing with the circle and you're going to make another perpendicular like that. So then this is the square. Alright? I'll add some more words for the online version of this answer key, but that I would just write down. Alright. The following, this is optical illusion art. It's called op art. Okay? Know your different types of geometric art. Then solve for the missing variables. Try to go for exact answers, but then convert that to decimal form. Alright, sometimes they'll be the same. If you do the math here, you get 24 squared plus 32 squared equals x squared. Okay, and have your calculator, know how to use it. Turn that on. So if I have 24 squared plus 32 squared, I hit enter, I get 1600. So 1600 is equal to x squared. You can definitely go through the factor tree to see what the exact radical form is and simplify, but it doesn't hurt to first take the square root. So if I do second square root and then do second answer, I will get 40. Well, it turns out that this is exactly equal to 40. So you'd save yourself a little bit of time going through the factor tree and simplifying that just to pull out all the numbers that multiply back to make 40. Alright, so for this one, now this is 8, so I write 4 squared plus w squared equals 8 squared. 16 plus w squared equals 64. W squared equals, what is that, 48. And so now I am going to do my 2 and 24, my factor tree, 2 and 12, and 2 and 6, and 2 and 3. And when I get my hockey stick, I'm looking for pairs of numbers. There's a pair of 2's, so I write 2. There's another pair of 2's times another 2. And there's lonely old 3 that's left behind in the radical. And then 2 times 2 is 4. 4 radical 3 is my exact. And my decimal approximation, well, 49 is 7, so you know that this is going to be like 6.9 something. We can see how square root of 48 is 6.928. And round it, and that is correct. So there's your best answer for that one. Number 3, telling you that this is 30 degrees. Once you see a special angle, 30 degrees with a 90 degrees, you know it's 30, 60, 90. The only other one you want to look for is 45 degree. This is the one that has the special relationship where you can save yourself a lot of time. This is the short leg, SL. This is the long leg, and this is the hypotenuse. And it's worth memorizing that the hypotenuse is always double the short leg. So x is equal to 10. That didn't take long. And then y is equal to 5 radical 3 is the magic multiplier. When you've got a 3 for 30, that's the little clue that it's going to be radical 3 is your multiplier. If you use SOHCAHTOA, you can also do it that way, and you'll see that this is the opposite side. This is the hypotenuse, and this is the adjacent side. And if you want to solve for x, well, that's the hypotenuse and the opposite side, so that's sine. You'd write sine of 30 degrees is equal to 5 over x. Remember Mr. Olson's little switcheroo? X then is equal to 5 divided by sine of 30, which when you put that in your calculator gives you 10. And then when you use Pythagoras to square and subtract, then y is equal to the square root of 75, and then that gives you 5 radical 3 that way. So it's possible to get the exact same right answers using SOHCAHTOA. So make sure you know that. TOA. Alright, down here, the only way to do this is with SOHCAHTOA. This is the opposite side. I don't know that. I don't care about it. I do care about the fact that this is the hypotenuse and this is the adjacent side. So that's cosine. That's ka has adjacent and hypotenuse in it. So cosine of w is equal to 7, the adjacent side, over 16. How do I get w by itself? I have to do the opposite of cosine, which is inverse cosine. So that's cos to the minus 1 of 7/16. We always do the minus 1 when we're looking for an angle. Whenever the variable's in the angle, we use the minus 1 thing. If we're given the angle like we are up here, then we do it straight up. So I type in second cosine, 7 divided by 16, and I get 64, about 0.1 degrees, approximately 64.1 degrees. All right. On to the last page. How long is the diagonal of a square with sides of 10 centimeters? Okay, expect at least one word problem. This is not a very involved one, but if this is 10 and this is 10, then again, exact form, this is that 45, 45, shortcut 2 equal angles, the multiplier is radical 2. This is 10 radical 2. Is the approximate answer is 14.14. Find the area of this triangle. To find the area, we need to sort of think, well, if this was a rectangle, it would be the length times the width, and then I cut that in half. That's how we find the area formula for a triangle, base times height. Well, what is this base? This is the famous 3, 4, 5 right triangle. 5 squared, call that, I don't know, w, equals 3 squared plus w squared. 25 equals 9 plus w squared. So 16 equals w squared. So w equals 4. And when I plug this in up here, I get 1/2 4 times 3. That's equal to 1/2 of 12, which is 6. So that's the area of that triangle. Similar triangles, you just set up similar parts in ratio. So 4, if I go from 4 to 10, 4 over 10 is going to be equal to 2 over x. And you cross multiply, 20 equals 4x. So x then is equal to 20 over 4, which equals 5. Okay. Finally, a circle fits perfectly around a square. Find the area of the circle if the length of one side of the square is 8. So again, it's one of those special geometric shapes, the square. We're trying to find the area of the entire circle. To do that, all I need is the radius. What is the radius? Well, from the center, I go to where it touches right here. Okay, so this is really asking what's the diameter of this so I can cut it in half. Well, that's just like the problem up here with the square that we're cutting in half. So if it's a square with a length of 8 on a side, then this is 8 radical 2. I want half of that for the radius. So if the diameter equals 8 radical 2, the radius equals 4 radical 2, and now I can put it into the area formula, which is pi r squared. Okay, so that means it's equal to pi times 4 radical 2 squared. All right. You know, if you put that in your calculator and type it in like that and square it, it will give you the correct answer, but it'll multiply pi in there. In exact form, I'm running out of room here, but I guess I'll put it right here. In exact form, when you multiply something times itself, 4 times 4 is 16, radical 2 times radical 2 is 2, 2 times 16 is 32. You'd write it as 32 pi is the exact answer, but then when you multiply it, you can take 32 times pi and get 100.53, very close to 100. 100.1, my favorite radio station. All right, expect some word problems, expect maybe a few more SOHCAHTOA problems, but that's very similar to what will be on the test. Good luck.